Okay, here's a little more practice on section 6.2. I'm going to randomly do 3 problems, but this is pretty representative of many of the problems in 6.2. So problem number 52, square root of 49 x to the 5th. Okay, we're asked to simplify this. Now we look at the 49 and the x to the 5th as 2 separate items. We take the square root of each separately. So let's start with 49. The square root of 49 is 7. So 7 can come out of the square root. Now we have x to the 5th. Think of x to the 5th as x times x times x times x times x. There's 5 of them. Because this is a square root problem, we're looking for pairs. We have 2 pairs. Each of those pairs comes out as an x. So we can effectively pull out x times x, or x squared. So we can add that to our answer, and that leaves one x left over, and that leftover x stays under the radical. So we can rewrite this square root of 49x to the 5th is 7x squared square root of x. Let's look at number 53. In number 53, the problem is the 4th root of 12x squared y to the 6th z to the 12th. Because it's a 4th root, we're looking for groups of 4. Let's start with the number 12. If we break 12 down, we see that we do not have any groups of 4. Therefore, the 12 has to stay under the root sign. Nothing can come out. Let's look at the x squared. Well, x squared is the same as x times x. We can't make a group of 4 out of the x's. So the x squared stays under the radical sign. Let's move on to y to the 6th. Y to the 6th looks like that, and we can in fact make a group of 4. That group of 4 comes out as y, and there are 2 left over. Then we look at z to the 12th. Well, z to the 12th, I can make exactly 3 groups of 4. So when I take all of that to write my answer, I start with the 12. Remember, the 12 had no groups of 4, so that stays in. The x squared, I could not make any groups of 4. That stays under. Y to the 6th, we said we can take out 1 group of 4, and there were 2 that needed to stay under. And with z to the 12th, I had exactly 3 groups, so I can take out those 3 groups, and it has nothing left over. And that would be the answer. Lastly, in number 54, the problem is to multiply the cube root of 4x cubed y to the 5th times the cube root 12y squared. Because these are both cube roots, I can combine them using the product rule. So when I combine all that, I get 12 times 4, or 48, x cubed, and then I have y to the 5th times y squared, which is y to the 7th. Now, what can I take out? Well, if I look at 48, 48 is 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Do I have a group of 3? And I do. I have 1 group of 3, and a 2 and a 3 left over. So for my answer, I can pull out a 2, and 6 are left over, the 2 and the 3 over here. When I look at the x cubed, I can create exactly 1 group of 3 out of x cubed, and that comes out as an x. And then y to the 7th, I can get exactly 2 groups of 3 with 1 left over. So if I were to write my final answer, I would get 2x y squared cube root of 6y. Hopefully that's helpful. Good luck.